Hey guys, so today we're going to be talking about something called simple interest. And if you've ever heard of a credit card company letting you borrow their money, but because they're letting you borrow their money, they're gonna charge you interest, especially if you don't pay it back on time, right? Or if you invest your money, maybe you earn interest on that. You earn more money because you invested your money like in a company that's doing really well. So we're going to talk about that kind of stuff today. It's very different than compound interest, which we'll talk about over the next few days. So simple interest, when you deposit money in a bank account, the bank pays you interest for the right to borrow, to use your money for a period of time. All right. So we have a simple interest formula, and this is what we're going to write down here. Simple interest formula is going to be equal to, interest will be equal to P times R times T. So what does P stand for? What do all these things stand for? Well, they're over here. All right. P stands for principal, and principal is the original amount of money that you deposited. In this situation right here, the principal or the amount of money you borrowed is going to be $100. All right. That's let's actually talk about being deposited. All right. You deposit $100, right, and then you're going to earn interest later. All right. So we deposit $100. That's the principal. R is the interest rate. All right. So that's the interest that you will earn as a percent. So they're saying that we will earn a 2% interest rate every year. So we're going to earn 2% of $100 every single year. Okay. And then times T stands for time. And time is always going to be in years. In years. All right. That's really important to remember. Okay. So here's the situation. We've got our interest as being equivalent to the principal times the rate times the time. So our principal was 100. All right. So we're going to take a calculator here, and P is right here. So this is the principal. We're going to multiply it by the rate, which is 2%, which is 0.02. And then we're going to multiply that by the number of years, which will be, for this situation right here, 1 year. And if we press enter, we find out that's $2. So that $2 is the interest that we earned by essentially putting $100 in the bank and letting it grow 2% for that 1 year. So now we still have our $100 in the bank, but we also have 2% interest. All right. And if we do that another year, if we let it sit there, let our principal sit there for 2 years, instead of 100 times 0.02 times 1, it's going to be 100 times 0.02, our interest rate, times now 2 years. All right. PRT. All right. And that'll be the interest we have earned. So this is now the new amount of interest that we've earned. We've now earned $4 by letting it sit there for 2 years. All right. So my quick question for you is, what does this represent? And as you may recall, that's the interest we've earned after 3 years. It'll be $6. So at the end of 3 years, we have $106 in our bank account. All right, that's the interest we've earned after 3 years. $106 sitting in our bank account. All right, that's kind of the basic idea here. So we'll move on. Suppose you deposit $400 in a savings account and keep it in the bank for 6 years. The annual interest rate is 5%. We're going to fill all of this in. All right. So the interest, that's I, right? Principal is P. Rate is R. Time is T. And we're going to plug in what we know. We're going to calculate the interest. That's something we don't know yet, but we do know the principal. That's how much money we started with. How much money did we start with? There it is, $400. Okay, so $400 multiplied by the rate. Where's the rate? Well, that's not the rate. Here's the interest rate, right? 5%. But we're not going to get tricked and put 5 there. We're going to write 5% as a decimal, which is 0.05. Very good. And then we're going to multiply that by the amount of time that we are allowing our money to grow. It's in there for 6 years, right? Time. It's always going to be in years. So we're going to put 6 because that's in years. And then if you take 400 multiplied by 0.05 times 6, you will get 120, right? So that is the amount of interest that we will have earned after 6 years if we put $400 in at the beginning and let it grow at 5%. All right, that's the basic idea. Moving on to part 2, the principal in an account, which is what you started with, plus the accumulated interest is going to be called the balance. All right, that's how much you have left in your account at the very end of the whatever amount of years. So $100 here after 0 years. What do you think that is? Very good. That's the principal. That's what we started with. All right, and then we're letting our money grow. We're still going to have the principal, but after 1 year we have $2. After 2 years we have $4 extra, and after 3 years we have $6 extra. What was that $6 extra from earlier called? Good. That's called the interest. And then both of these combined, right? The interest plus the principal is going to be called our new balance. All right. So moving on to part 3, or no, part 2 example. Oh my, here we go. All right, bank manager wants to encourage customers to open a CD, a certificate of deposit, and he makes this poster, and we have to essentially help him complete this table here. So he says, if you deposit $2,500 at 3.5% annual interest, that means interest earned every year, annually, all right, that means every year, we have to fill this in. So time, after a certain number of years, how much simple interest will we have earned, and then what will the new account balance be? So we're going to have to use our interest equals P times R times T equation. Okay, what's the principal here? What amount of money did we start with? Very good, $2,500. So let's put $2,500 right there. Let's multiply it by the rate. What's the rate? The interest rate we're earning, 3.5%. Let's write it as a decimal. 0.035. Be very careful. 3.5, divide it by 100. That's 0.035. And then multiply that by the time. Well, in this first row, we're going to say time is 0. All right, we have to fill that in. So if time is 0, I mean, you could very easily mentally do this. Any number times 0 is going to equal 0. And that means our interest will be 0 because it hasn't spent any time in the bank, right? It's been 0 years, so our interest that we've earned is still 0. But what's our new account balance? Has our account balance changed at all? No, it hasn't, right? We still have our $2,500 that we started with. It just hasn't sat in the bank at all, so we haven't earned any interest on it. So let's do for 1 year. How about after 1 year? We still have the same principal. It's being multiplied by 0.035, and that's the interest rate. And then now it's not sitting in there for 0 years. It's sitting in there for 1 year. So we're going to put a 1 in for T. And then we need to figure out what that equals. 2,500 times 0.035 times 1. 2,500 times 0.035 times 1. 87, oh, there you go, 87.5. And if we do that in dollars and cents, let's make sense of that. That's 87.50, $87.50, right? So that's the interest that we will have earned after 1 year, $87.50. But what's our new account balance going to be? Very good. You're going to need to add the interest to the original account balance, right? So now we have 2,587.5. All right. So this is our new account balance. Let's do it for after 2 years. All right, 2,500, that's the original principal, times 0.035 times, now it's 2 years. Okay, so same equation. 2,500 times 0.035, but now we're going to multiply it by 2 years, and that will equal $175, right? That's the interest we will have earned after 2 years. This is where you have to be really careful. Every year we're earning how much interest? It's going up by $87.50, right? So we're not going to add 175 to this number. We're really only adding $87.50 to this number. Or you're adding 175, the interest, to the original balance, right? So now we really have $26.75. Okay? This is incredibly important. That's what you're adding your interest to, the original principal. Add your interest to the original principal. That'll give you your new balance. All right, and you'd complete the rest of the table. I'll let you do that. In some situations, interest is accumulated on a monthly basis instead of yearly. So to find out how much interest you have after 3 months, you need to convert months into years. That's really important to do, all right? Because interest is always earned in T amount of time, which is in years. So if we've earned interest for 3 months, 3 months time, 3 out of 12 months, right? 3 months out of 12 months, which is a year, reduces down to 1/4. So essentially 3 months, and thanks for writing this down, is 1/4 of a year. 3 months is 1/4 of a year, 3 out of 12, okay? And then you reduce that down. Okay, the last part here, after 8 months, does Mia still have the higher balance? And then explain. So let's look. Alex, for this account, started with $29.50, and he earns 4% every year. Mia, though, has a higher principal, but she has a lower interest rate. She's going to earn less each year. Starts with more, but she's going to earning less. So after 8 months, we have to figure out, does Mia still have the higher balance or not? Okay, using your equation, I equals P times R times T. Let's write that down. We have to figure this out. So the principal, $29.50, times the rate, which is 4%, turn it into a decimal, times the amount of time. Okay, what was the amount of time? They said it was 8 months. Well, what's 8 months written as a year, right? That's 8 out of 12. 8 out of 12. So $29.50 times 0.04 times 8 out of 12. Well, 8, I'm so sorry, here we go. Now you can see it. Hey, $29.50 times 0.04 times, well, 8 divided by 12, that's 0.75, right? 3/4. No, it's not. Is it? Uh-oh. Let's do this. 8 divided by 12. Oh my, what a goofball. Holy cow. Nope. 8 divided by 12 is 2/3. So 0.66. We're going to use 0.66666666. So you should type in your calculator when you do this, like 0.666, type a bunch of sixes when you do this, and then you'll get probably really close to the answer. All right, it's 0.6 repeating. So let's figure out how much money Alex has. $29.50 times 0.04 times 0.6666666. See what I'm doing, right? And the sixes go on forever. And then you'll get a number that's really close to what it should be. $78.67-ish cents, right, will be the interest that Alex has earned, $78.67. However, what's his balance going to be? It's not just going to be this. That's just the interest he's earned, right? That's just the interest. So let's add that good to the principal. $29.50 plus $78.67. $78.67. I'm just going to add this answer plus $29.50 to the original balance. And Alex right now has $3,028.60, roughly 67 cents. That's his balance. We need to figure out how much Mia will have after that same amount of time after 8 months. So start with the same equation, I equals P times R times T. She has a new principal though. She has a different principal. Multiply it by a different interest rate, and then multiply it by time, which was 8 months, 8 out of 12, which we said was 0.66666 repeating. And then I'll let you take it from there, and you can figure out, does Mia actually have a larger balance now, or does Alex? All right, so go get them. I will let you know, though, that the homework that you're going to do after this, and make sure you do this entire notes page, right? The homework you're going to do after this, it's going to have some tough questions on it, so do your best, use this equation, and if you've got any questions, let me know tomorrow. Okay, we're going to spend multiple days on this topic because it's kind of tough. All right, so do your best, use your notes to help you, and we will see you soon. Bye.